Hello everyone, welcome to Murat Karakaya Academy YouTube channel. In this tutorial, I am going to talk about how to integrate AI in software development by using two important methods. One of them is structure output and the other is function calling. So when we talk about AI and software, actually I would like to mention three dimensions of that interaction. One is AI-driven software development. AI-driven software development mainly focus on how to implement AI theories as a software. So the second one is AI-enhanced software development. In AI-enhanced software development, actually, we use the AI capabilities to enhance our software development cycles. And the last one is AI embedded software development. In that kind of software, actually we are coding traditionally, but adding AI into it so to make our codes more intelligent than before. In that tutorial, I am going to talk about AI embedded software. So the questions that how to embed AI into our traditional software. So in that presentation, actually, I will provide you the introduction. Then I will do some demonstration how to embed the AI into your regular codes by using two important metrics, structure output and function calling. And in the upcoming tutorials, I would like to talk about multi-agent systems, retrieval augmented generation RAG shortly. And in the third upcoming tutorial, I would like to talk limitations and challenges of all these methods and feature direction and software in software development. Therefore, this in that three tutorial series, I will talk about mainly the why we need AI integration, how to do AI integration, and it is challenges and of course opportunities. So if you would like to, you please subscribe to Murat Karakaya Academy YouTube channel. As you know that in Murat Karakaya Academy YouTube channel, we have several tutorials about the software engineering and AI and how to apply AI in real life world. Plus, I provide the practical implementation of the theoretical parts of the AI. So let's continue today's topic. So if you are watching this tutorial, I know that you know a lot of large language models. So around the large language models, actually, there are many concepts and techniques which enables LLM exist or LLM operates. Of course, in one tutorial, I cannot cover all these techniques, concepts, but we know that large language models now are the leading power in AI today. Therefore, in that tutorial, when I refer to AI, mostly I refer to large language models, capabilities and capacity. Of course, there are other vision or video based or there are the other machine learning techniques could be considered as AI. But for the moment, as you know that we can think of the AI is the pinnacle, the LLMs are the pinnacle of the AI today. Why? Because LLMs can exhibit some advanced reasoning and problem solving capabilities, so they can mimic human-like reasoning by generating solutions based on complex inputs and outputs. They can also capable of handling diverse problems from code generation to debugging or summarization to interact with the human beings in different contexts. If we the other advantage of LLMs, adaptability and generalization. So the large language models can easily adapt to different domains. For example, they can work They can easily learn the terminology in, for example, medical sciences, and they also can easily learn how to code. So they can show that if we have a foundation model, we can easily fine-tune this model into new domains. Also, they provide the context-aware intelligence. So when you interact with a large language model, actually large language model does not only use its trained data, but it also take care of your current interaction with the model, so they can react according to the context. Also, we can think about the self-learning and continuous improvement. Of course, by using fine-tuning and other some new methods, we can use the already trained model and change its or provide this adaptability and generalization to new domains, and that makes the large language models very efficient for different areas of life. But the question is that how can we use LLMs as our intelligence in our traditional coding? As we know that even they have been only 2 years that AI or LLMs are accessible to all the public, and now we are at the edge of a transformation so that we can use the already accessible models into our coding environment. But the keyword is here: how can we trust them to provide the expected answers from large language models? Large language models have lots of limitations. I would like to talk about these limitations later, but just to note that the most important constraint is that large language models are stochastic models. So since they are stochastic, they can reply the same question with different answers, which sometimes is advantage, but sometimes not disadvantage. Why? Because in coding, of course, we would like to, most of the time, we would like to generate deterministic applications. So whenever we run the code for the same input, we hope that, we expect that it would end up with the same result. But if you use a stochastic model, large language model, in your application, how can you guarantee that? That's the one important question among many others. I would like to talk about these limitations, risks, or challenges in the next tutorial. Now, we will focus on how to build application on large language models by using today's technology. There are actually 4 important technologies, but today I would like to cover 2 of them, which are structure output and function calling. So my aim is to show you how to use the output of large language model as a part of our coding process. Before getting into details, let me give you the very simple use case, ATM machine. So assume that you would like to write a simple Python code just to provide some user can deposit, withdraw, or learn interest rates. So you see that by using, for example, Gemini, you can easily generate this code, and then we can use. So here you see the class bank account is generated. So we have the methods here, class method, deposit, withdraw, and get interest rates. So these are very, very simple examples. So we just create an object from that class, and while true, we provide the menu selection 1, 2, 3, 4 and exit. And then according to the choice, we call the function accordingly. We also have the some error handling methods. So here you see that when we run this code, we can provide the options provided us. So if you enter the option 1, so you need to provide some deposit. If it is negative, you see that there is the error handling as well. So you can provide the, for example, 3. So you learn the account interest rates, and also you can try withdraw money. So basically at the beginning we have $5,000. If you request $10,000, it would say that insufficient funds. So this is the very simple example. So we are gonna try to embed the AI or LLM capabilities to interact with these simple functions or simple ATM machine. All right. Let's move on if you like. I think it's very simple and understandable. So let's move to the how to do all these changes into our code. So the first method I would like to talk about is structure output. I will talk about first why we need the structure output and how to use the structure output in our coding, the ATM coding example. And in that demo, I would like to show you how to understand the customer intent. So after understanding the customer intent, we can call the required function. So let's begin the definition of the structure output. As you know that the large language model mostly text in and text out models. So you provide a prompt in text and you get a reply or response in text. But in coding, the free text cannot be, maybe most of the time we cannot use the free text in our coding. For example, when I mention coding, I most probably be clear that in coding we have some structures like loop structures for while, or we have the selection structure, for example, if, else structures. So I would like to use large language models reasoning capabilities in these kinds of structures. Therefore, if I have only from the large language models output as free style text, then I cannot integrate these output into my loop structures or selection structures. So therefore, the large language model trainers train that models or fine-tune that models so that they can produce some structure output, not only free text. This structure output can be JSON, XML, or Pydantic models. So they can follow the given schema and produce the output accordingly. If the models are fine-tuned to reply by following the given schemas, formats, then we have the key characteristics or advantages of these kind of large language models. First of all, consistency. So the output will have follow a format or schema. So we expect the schema, for example, the first would be the name, the other would be the last name. So we would have this consistency. The second and most important thing, we are going to use these output in our coding. So our code should read and understand the output of the large language model. So it should be machine readable. And as you know that JSON, XML, and Pydantic models supports these idea actually, machine readable. And the validation is, of course, because of the consistency, machine readable, and because of we provide the schema, we can validate the output. If there is some error in the output, we can request the large language model to produce the output again until it respects the schemas given to it. Let me show you some simple example first of all. Here you see that a JSON schema which captures essential information about the conference call information, so it can summarize. if you, for example, assume that you provide a conference call to a large language model and you can ask that summarize these conference, it can summarize, but it can be readable only by human. But if you see that in that JSON object, I guide it with a structure. In that structure, I just said that for each conference, the JSON object should begin with conference. Then there should be name, location, dates. And in dates, there must be start date and end date. And there should be a list of organizers, a list of participants, a list of publications, a list of awards, a contact as an email. So when you provide this structure, if the large language model is fine-tuned to output, structure output, then we will be very happy. Let me show you this. Now I provide this as a prompt to the large language model, and then I got the conference call from the website and provide this conference call, a very long text. Now look at this. Here the output is not anymore free text. Now you see that the output is the JSON object following the JSON schema I provided. That's very useful if you are gonna provide these JSON object to any coding environment. So you would see that here publications are, for example, a list of 3 journals, and awards, you see that there are 4 best paper awards, and the contact, you can see the email field here. So this is the actually the structure output from a large language model. Let's continue. So in the coding, we need this structure output, as I tried to explain. First, reliability. So we need to ensure that the contact information in terms of email must be exist in the answer from the or reply from the large language model. So if you provide this schema to a large language model which has the capability of producing structure output, then you have increased the reliability. Because otherwise, if you ask what is the conference email, then in free text it can reply. But you cannot use this reply, and you cannot rely that this reply is correct. But by using the structure output, if the model is already fine-tuned, the model understands what your request is exactly. So when you say it's email, it would understand only the email it should return. So interoperability actually here is the we can use this output in our code in any function. For example, we can pass this to the insert this conference call into a database. So for any conference call, we can generate the same JSON object. Therefore, our insert method into a database would work with any conference call. Because of that, it means that you can begin with a free text like conference call, and you can automate all your code according to the LMS, large language models, output, structure output. And of course, this will reduce the errors that you can arise from the free text from the conference call. But of course, we can minimize the errors, but we cannot make it 0. I will explain later. The structure output, how can we get the structure output? First, you need to define the format, of course. You need to provide the schema and along with the validation rules. Then you can provide the data elements, fields, and attributes. Also, you can provide the nested structures. And most of the time, you need to take care of the errors produced by the large language model, and you need to log all the results and monitor all the results. Maybe you need to request a large language model to produce the expected structure output. Now let me explain how we are gonna integrate this. Here you see that I already integrate the Gemini API and asking that, let me stop here. Let me move a little bit back. Okay. Here you would see that we already integrate the large language model Gemini API, and then here is the configuration. Here is the configuration, as you see that. In that configuration file, actually, we here provide the output should be not free text, but out should be a JSON object. That's important. So the Google Gemini Flash model I will use, the Flash 1.5 Flash, actually fine-tuned to generate JSON objects. So I will use these. After that, we provide a system prompt. As you know that the system prompts are the main prompts for large language models. So they can play their roles in the prompt exchanges or in chat exchanges, message exchanges. Here you see that I provide that the output format must be a JSON object. The schema should be like that. And there are some examples. These examples are few-shot learning examples. As you know that it is a prompt engineering method. So I provide these few shots, and then the large language model now are ready. So I provide all the necessary information and I just run the chat model. So here you see that there is a simple function. Let me stop here. Now in that simple function, input chat. So input chat, the idea is that I will use the large language model capability to understand what is going on with user and what the user intent is. Let me go back here. If you check these examples, the large language model will provide me action, stop or continue. So stop or continue means that I need to continue with chatting the user or not. So content is 1, 2, 3, 4 means that deposit or stop. So let me go a little bit higher. Here, if you check that 1 is deposit, 2 is withdraw, 3 is interest rate, and 4 is exit. So according to this given, let me go a little bit, it can generate the decision to continue or stop. If it stops, it means that it understands the customer intent to withdraw money or to deposit money or exit, etc. But if it continues, decides to continue, it means that it has some more questions to ask the user. The probability is the certainty of the decision here. So let's continue with the input. Okay, here in that input function, actually, I initialize the chat with the customer, and then as you see that we get the decision from the large language model, and according to the decision JSON object, if the action is continue or if the probability is less than 0.70, actually we need to ask the user with the clerk request, and then we get the user message and then send back to large language model, and then we get the large language model and check its decision in that while loop. As you see that in that while loop, we can use the decision object which returns by the JSON library from the response, from the large language model response, as just a dictionary. So you see that if that dictionary action item has the value continue, do this. Or if the decision probability field has this value, do this. Otherwise, if the action is stop, then we will just leave this loop, and now we can use the decision content with certainty. We will print the clerk decision on the screen. Let's move on. Okay. As you remember that this is the JSON schema we provided, so we will use the JSON schema here. All right. Now, if you come to our main, now this input chat begins with the hello, and we get the choice. According to the choice, we run the required main function. But please pay attention that input chat, actually, as we've seen before, is the result from large language model interaction with user. And let's run this code and see how it interacts with. Now, clerk says, welcome to our bank. How can I help today? So actually, it starts the chat with us. And I said that I need money and happiness. And clerk says, I understand you need money. Would you like to withdraw some funds? Here I want to stop. As you see that actually I provide not official reply, but it would understand it tries to understand my intent and try to clarify. So it decides to actually move on with the questions. Let's continue. Sounds good to me, I answered. And now let me stop here. Now clerk says that my option is to, which is withdraw, and 0.95 here, as you see, that means that with the probability of 95%, it is sure about that I want to withdraw money. Then it exists the rule loop, as you see that here. Oops, I am sorry. Let me go here. I am sorry. Here with the options, it understands, it goes to choice 2. Let's move where we left off. Okay. Now I enter some values to withdraw, and function is done. And the clerk is there asking, is there anything else I can help with today? And as you might remember, I didn't write this kind of interaction statements. It's done automatically by large language model. Now I said that I need to interest rate with 10%. What should I get this? And it understands my intent and provides the interest rate automatically, as you see. So I said that I have lots of money but no comfort. So you are looking for comfort. Would you like to learn more about deposit options? So it could easily understand my free text, my intent, and it can understand that I want to deposit money with 90% certainty. Now I can deposit money. And you see that here the interaction with the code is totally changed. And when I said good to go, it just understand 100% that I would like to exit. So by just adding one function here, input chat function, I didn't change the rest of the code, but now I have the power of large language model with interaction with user. So when the user provides any message, I pass this message to the large language model, and large language model provides me a structure output. And according to this structure output, I decide the action, continue or stop. And then I also understood what to show the user and which function should I take. That's the ability gained by structure output. As you see that we now integrate the large language model or the AI into my simple code, traditional code, and you might notice the power of that. The power mainly is that you can customize the interaction with the user, and you can handle many different input kinds with ease. Of course, there are some potential risks here, but I will talk about the risks and the potentials in the next upcoming tutorial. Let's move on. The second method that I would like to show you is function calling. Actually, function calling is based on structure output, but it's much more detailed. So we are gonna see again what is function calling, why do we need function calling, the main components of function calling, and we will continue with our ATM example. The function calling in large language model actually allows you from the provided chat or the text or the prompt, the large language model would understand two things. So if it needs to continue chat, or if it can select one of the functions to be run by the system. So that is the function calling. Actually, large language model does not call any function. It just decides which function should be called with which parameter values. So let me show you one simple example to make it concrete. So in a prompt, you can provide a list of functions as you see here. In that prompt, you see that I provide the functions delivery cost and tax. As you see, these are just the simple Python functions. Then I provide a context. This context could be a prompt, this could be a chat, a long chat, whatever. Then the system prompt actually looks like that. Decide and output only the function name, the parameter name, and value based on the context and function definitions. So if I provide all this to large language model, as you see that at the bottom, replies that tax in parentheses amount is 150. So what I try to show you that a large language model would understand from the context which function should be called with which parameter value. If we continue like that, now I have again the same function list. Now the context is a little bit different. I bought a TV from Istanbul. Ankara is 500 kilometers away from Istanbul. The cost of the TV is $100. So decide the output and only the function names and the parameter values. Here you see that the ChatGPT outputs two function names with two parameter values. So in that example, as you see and notice that the large language model actually is capable of deciding more than one function should be called with the proper parameters. So the function calling is all about this, but of course not in a prompt, but in coding. So by using the function calling, actually we now have the structure interaction with large language model and between the large language model and the code. So the code can now provide some free text and a list of functions, and depends on the large language model reasoning capabilities. The large language model can guide the code if any function should be called or not, if it is to be called, with which parameter values should be called. After then calling the function, most of the time function has a result, and then we can use this result and provide the result to the model. The large language model now has the context, now has the result from the function. Now it can put these two things together to generate the final result to the user. By using the function calls, actually the large language models now can decrease the hallucinations, and they use the accurate results from the environment, or from, when I say environment, from a database, from an API call, and there could be many. And by using this function call capability, now we can actually integrate the large language model into our complex tasks, understanding the free text from the user or the whole chat or from a document. The steps or the components in function calling like that, we need to first provide the function list. Then the large language model just understands the free text and then returns a JSON object or XML object. We need to parse these XML object, and then we need to map the functions from the large language model, maps the text to the function list, and then we need to get this input, and then we can need to run the correct function with the selected parameter values. After that, we need to provide the output to the large language model, and large language model will provide the answer response to the user prompt. Now here I would like to show you very simple implementation. Again, I am going to use the ATM demo. Here, as you know that the balance I already initialized 5,000. Now we have the deposit, withdraw, exchange rates. Now I added these exchange rates. Let me explain. Stop that. Because I would like to show you that my code or large language model, because of my code, now it will, the large language model will access to the current exchange rates through an API or microservice. So I will use the exchange rate website. They provide an API. So when you provide some currency, it will return you the values for all the corresponding other currencies. So here I would like to show you that now my large language model will be able to get the information from the environment, the API, through the API or the microservices. Let's continue. Here is the API URL, and now we have the from currency to currency. So I will provide the from currency to the API. After that, API returns me some answer, and by using the to currency, I will get the value of that exchange rate and return it. So that's how we can do. Here is the exit chat. So we have basically, if you check again, 4 functions: deposit, withdraw, get exchange rates through an API. It's important. It's not local function. Now we provide these function lists to large language model, and we will have a dictionary, as you see here. I will use this dictionary to call the function in code. So still we have the system function, system instruction. So in that system instruction, I clearly noticed that there are 4 functions to be selected. And then actually here I would like to show you that if large language model selects a function and returns me in the response, I will get these function name arguments from the response, parsing the response, and I will just call this function with the provided parameter value. I will get this result if the function works correctly, and I will return this result to be returned to large language model. Okay, that's the execute operation function does. So basically, I will just run the function selected by the large language model with the total parameters. Now, initialization chat system, basically I provide the configuration. In that configuration, I provide the tools parameter. So in that tools parameter, I provide a list of functions. Also, I provide the system instructions. So I initialize the model and return the chat object. So by using the chat, now I just initialize the chat and provide the first hello request. While true, I will repeat this loop until the goodbye is the clerk result or the clerk decision. Okay. In that loop, actually, if you look at that, first I get the user request and then send to the LLM. LLM will return the response. In that response, I am going to look if there is a function calling or not. So basically, if there is a function calling, I will execute it and I will show what the function returns to you. So there are two options for the LMS. In the first option, LLM can return the to be called function, or LLM can decide just replying a text to the user. So I will pass this text to the user. If large language model decides a function, I will run the function, then I will provide the result from the function to the LLM with chat send message, so that large language model is aware of the result from that model, that function. Okay, let's see how it works. So I run this again. Now it salutes us. So I will reply with saying that I will go to holiday soon. And it replies, exchange some money. It infers that I would like to exchange some money. I said, nope. So it asked me what to do today. So it just lists me the functions. I just say $1,000 equals how much Turkish liras. So it would understand check the exchange rate. It asks me confirm. So I would say yep. And now, as you see that it understood and called the get exchange rate function. The function returns this, and all this result actually happens here. So we just run this selected function, and here we provided the output and returned the output to the, actually, as you see here, we run here we get the selected response. This response holds and function call. We run the function call. Now we get the result. Here is the function return result. As you see that we have seen the function return result. And now this is the answer from the large language model. Because it knows the rate, it calculates the 1,000 USD in Turkish liras. All right. Now I switch to Turkish. As you see that in my prompt. Evet, 1000 TL kaç dolar eder? Here as you see that it replies me immediately in Turkish. It's the beauty of large language model. It can handle almost in any language. And then it requests me confirmation I provided. It again calls. This time it just calls with the from to rates accordingly. And it replies me in Turkish, calculating the correct amount by using the current amount from the function result. So that I now connected my large language model to internet almost. Now I continue with request in English. It continues with the exchanging messages in English because I switched to English. And then it requires me confirmation. I said positive, and then amount it asks because it will need to call the function with the amount, and it needs another confirmation. I said yes. Now as you see that it's called the deposit function, and now if you check that it decides the function and it calls the correct function and returns the result. But at that point, let me comment all these print statements because this print statement is just to show you how it interacts inside the code. Okay, now let's run everything from scratch. And this time you would see that the interaction, how actually it interacts with the user. So now let's see again. So you write some amount to, in Turkish I would say 1000 Türk lirasıyla kaç dolar alabilirim? How much dollars can I buy? Now it interacts like that. So it is very natural, as you see, very natural. And then I just say please. Now also it provides the correct answer by just calling the behind the scenes the API service. Now extra, I would like to ask the question that how much $100 makes in Turkish liras. As you see that it is very fast and it calculates the correct amount by using the exchange rate behind the scenes. So as you see here that now I have added some intelligence to my code, and also now my large language model connected to some API. Here I requested much amount money, then I have the balance. Let's see. Basically the function only returns that I cannot get it. Now we have a beautiful message from the large language model. When I say anything else, nothing, so it stops. All right. So we have seen that how can we integrate AI into our software development. So far we have seen two important methods. One is structure output, the other is function calling. As this is a live broadcasting, if you have any questions, I would like to answer, but I see there is no answer. But if you have watched so far, please click the like button, subscribe to the channel, or become a member. Thank you for watching. Take care. Bye bye.